Hey guys, Mr. A here. In case you didn't notice, I kind of just got done playing Undertale. Really enjoyed it, but not going to spend that time talking about this. Let's go ahead and dive in and talk a little bit about ratios and the big brother of them and the more useful application for ratios, rates and unit rates. But first, a quick little recap. What is a ratio again? All a ratio is a comparison of two numbers. Nothing more to it. Let me give you an example of that. Let's say some guy named Matt happened to have 12 sodas and 8 bags of popcorn. If that person were to have 12 cans of soda and 8 bags of popcorn, then his ratio of soda to popcorn would be 12 to 8. Or you could simplify it down and get 3 to 2. Jeez, that was a lot louder than I thought it was going to be. The other way that you could write those ratios, by the way, for those of you who remember, is you could either write it as a classic ratio form, you could change it and write it in word form, where you write out the word 2, or you could just rewrite it as a good old-fashioned fraction and put it as 3 over 2. Now that we got that out of the way, let's go ahead and talk about what a rate is. A rate is a very special kind of ratio. It's a ratio that makes the comparison of different measurements. Let's go ahead and talk about some examples. If I were to talk about a rate of production, let's say the number of videos I could possibly make in 2 weeks, I can probably make 5 videos in 2 weeks. Next, let's talk about rate of speed. A rate of speed might be if I were able to walk 10 miles in 2 hours. The point of all of this is that I am measuring videos compared to weeks. Those are two completely different units of measurement. Same with amount of time passed and the amount of distance traveled. But that's not why you're here today. You're here because you want to know a little bit more about unit rates. Well, to tell you the truth, you probably actually know a lot more than you think you do. Let me go ahead and throw a couple of example problems at you and see if you can figure it out. Here's a nice little website I like to go to from time to time to throw a few example problems at some of my students. Take a look at this problem right here and find the unit rate. If there were 12 stickers on 2 pages, then how many stickers are there on 1 page? A unit rate is just figuring out, based on this information, 12 stickers on 2 pages, how many stickers are there per page? You don't need me to tell you what a unit rate is in order to figure out that there are 6 stickers on 1 page. You already understand this. Okay? All I'm here to do is tell you the official vocabulary that you're going to need to use and help you understand what to do when the questions are not presented in such a cut and dry manner. So, what exactly is the textbook definition of a unit rate? A unit rate is a rate in which the second amount that is being compared is the number 1. So, for example, on the last one, when I was talking about 12 stickers on 2 pages, and I wanted to know how many stickers per page, if I am saying per page, that implies that there is only 1 single page. I am comparing 6 stickers to 1 page. I'm just not writing it as a 6-to-1 ratio. I'm stating, as a fact, that there are 6 stickers on 1 page. So what does that mean you're going to have to do most of the time? Are you going to constantly have to make a table and reduce down to the simplest fraction until the number on the right-hand side has become a 1? Not necessarily. The vast majority of the time, you're going to be able to tell what your unit is and what your rate is, and you're just going to have to divide your first unit, typically the number you would put on the left side of the ratio, by the number on your right side, your second unit. Let's go ahead and take a look at a few more examples. If I were to travel 280 miles in 4 hours, then how many miles per hour am I traveling? What I want you to do when you look at this type of problem, if you already understand that you are dealing with ratios and unit rates, I want you to look for a couple of key words. The first 2 keywords I'm going to need you to look for are the numbers that you already can tell that you are going to be dealing with. In our case, there are only 2 numbers ever mentioned in this problem, 280 miles and 4 hours. So let's go ahead and underline those and make sure that we keep track of them. The next key piece that we're going to be looking for is the word per. If you ever see the word per and a few others, which I'll get to in a minute, I need you to underline the words directly before and after that word. That's telling you what you are dividing by what. In this case, it mentioned miles first. It said miles per hour. So, what we're going to have to do is we're going to have to take our 280 miles and divide it by the number of hours, which in this case is 4. And our answer is going to come out to 70 miles over 1 hour, or simply put, 70 miles per hour. Now, as I just mentioned, there are a few phrases you're going to have to watch out for. One of them, as we already mentioned, is if it states that something per something else is being used. This is the most common one that you're ever going to see in a unit rate problem. It's not always going to be there, though. Sometimes you'll be reading a problem, and it might say, for every something. There may or may not be something directly in front of that. You're going to have to read into the sentence to see what it is trying to ask of you. And the last one you might see is something for each something else, or in some cases, something for every something else. It's not always going to be super clear, but 90% of the time you're going to be able to read a problem, much like the example we did earlier before I explained this to you, and you're generally going to understand what is being asked of you. And whenever you're in doubt of a problem, something is driving you nuts, but you know that you have to find an equivalent ratio, just think back and use a ratio table until you can get back to something that is being compared to 1. Here's an example. This problem threw all of my students off guard, and let's see if it throws you off too. For every 4 miles that Victor ran, Craig ran 3 miles. If Victor ran 1 mile, how far would Craig have run? Have run, have ran, have ran, have run? I don't know. If any of you guys know the answer to that, just post it somewhere in the comments, because I can't be bothered to look it up right now. Let's go ahead and put this all into a table, shall we? I went ahead and plugged this into my table, and I decided to put 3 to 4 into my ratio table. 3 representing the 3 miles Craig ran, and 4 representing the 4 miles Victor ran. So now that we've got this table figured out, let's go ahead and explore exactly what this problem is asking us for. It's not trying to ask what the unit rate is, not necessarily. Well, I suppose it is asking for the unit rate, but more specifically, it just wants to know how far did Craig run so far. So now that we understand that, we have to finish plugging in this table. Think back to the last video we did about simplifying and finding equivalent ratios and fractions. What we had to do is use our 1 times block and change it in order to find our new blocks. That's going to be a little different here, because you see, unlike the other table where we were either simplifying or expanding, this one already appears to be simplified. This is what we would call our 1 times block. Unfortunately, what the table is asking us to do is it wants us to figure out what this is. How are we taking that 4 and turning it into 1? And it's still leaving this area blank. It's not telling us anything about it. In fact, that's what it's asking us about. Think outside the box here. If I can't multiply my numerator and denominator, or the left and right side of my ratio by something, there must be another operation that can do things proportionately and evenly to both sides. You got it? It's division. I have to divide 4 by something in order to get 1, which I'm sure the moment I said that, many of you already understood. It's 4. That box has now become my divided by 4 box. Everything in my original ratio was divided by 4 in order to get me up to this point. So, what does that mean for the other side? You got it. I gotta divide it by 4. Okay? So, I'm not necessarily going to ask you to give me the decimal form. I want you to write 3 divided by 4 in a fraction. Go ahead, I'll wait. Got it? Good. The rest of this table is going to be filled with 3/4 or 3/4 or 75/100, whichever way you would prefer to write it, I'll accept it. What did we learn today? Well, we reviewed a little bit of ratios. We talked about what a rate is, and we talked about finding a unit rate, and we talked about finding a unit rate even when it turns out to be a fraction. And that's it. That's all we've covered today. I hope you found this video informative, and as always, I'm Mr. A. Have a nice night.